3 billion miles apart, two worlds that have nothing in common. One is buried in ice, so far from the sun that daylight there is barely a twilight. The other is wrapped in a thick orange fog, with rivers that never see a drop of water. Different sizes, different temperatures, different histories, different chemistry, different corners of the solar system entirely. And yet, when astronomers pointed the most powerful telescope ever built at both of them, they found the exact same thing, a signal, buried in light, coming from a molecule that, as far as anyone can tell, doesn't exist in any laboratory on Earth. Nobody has named it, nobody has explained it, and the more scientists study it, the stranger it gets. This is the story of a fingerprint with no suspect. To understand why this discovery stopped planetary scientists in their tracks, you have to understand just how little these two worlds are supposed to share. The first is Titan, Saturn's largest moon and one of the strangest places in the solar system. It's bigger than the planet Mercury. It has a thick atmosphere, thicker than Earth's, wrapped in a permanent orange haze. Beneath that haze, something extraordinary happens. Rain falls, rivers flow, and lakes fill entire basins. Titan is the only place beyond Earth where liquid moves openly across a solid surface. But it isn't water, it's methane. Titan runs on a completely different kind of weather, cold enough to make our oceans look like molten metal by comparison. Then there's Pluto. Small, frozen, and for decades, dismissed as a dead world. A ball of ice drifting through the dark, 4 times farther from the sun than Saturn. Its atmosphere is so thin, it's almost not there at all. Thousands of times less substantial than Titan's. One world is active, wet, and dense with atmosphere. The other is a frozen outpost at the edge of everything. They were never supposed to match. But here's where things get strange. To find something on a world billions of miles away, scientists don't send a probe to pick it up and bring it home. They read light. Every molecule that exists absorbs a very specific, very exact slice of the light spectrum. It's like a signature no two molecules write it quite the same way. When light bounces off a surface and travels back across the solar system to a telescope, some of those wavelengths are missing, swallowed up. And if you know which molecule absorbs which wavelength, that gap in the light tells you exactly what's down there without ever touching it. This is the same principle that lets astronomers detect the atmospheres of planets around other stars, light years away. And it's exactly how the James Webb Space Telescope studies the worlds inside our own solar system. Webb carries 2 instruments built for this kind of work, NIRSpec and MIRI, each tuned to read different bands of infrared light. When a research team, led by planetary scientist Bruno Bézard, began studying Titan's spectrum in detail, they noticed something that didn't belong: a gap, a dip in the light, at a very specific point around 5.1 micrometers. They checked it against methane. It didn't match. They checked it against every hydrocarbon in Titan's known chemistry. Still nothing. They ran it against published data for haze particles, ices, every compound in the books. Nothing lined up. And that's when the story changes. Bézard reached out to a colleague, planetary scientist Emmanuel Lelouch, who had been working with Webb's earlier observations of Pluto, captured back in 2023. He asked a simple question: had Lelouch seen anything unusual at that same exact wavelength? Lelouch checked. It was there, on Pluto, the same gap, the same signature, at the same precise point in the spectrum. 2 worlds, separated by billions of miles with almost nothing else in common, were absorbing light in exactly the same strange way. But there was a problem. It wasn't a perfect match. On Pluto, the signal was roughly 3 times wider than the one on Titan. The strength of the absorption, how deep the dip went, was similar on both worlds. But the shape was different. Scientists don't take that as a contradiction. They take it as a clue. A difference in width can point to how the molecule is arranged, what it's mixed with, or how temperature is shaping its structure on each world. Same fingerprint, different conditions leaving their mark on it. The team went back and checked their instruments for errors. They ran the numbers again. The signal held up on both of Webb's spectrometers, independently. This wasn't a glitch. Something real was sitting on the surface of 2 of the most different worlds in the solar system. and nobody could say what it was. Here's the detail that makes this even more surprising. This isn't a faint trace, buried at the edge of detectability. On Titan, the signal eats up 6 to 7% of the light at that wavelength. On Pluto, 4 to 5%. That's not a whisper. That's a real, measurable, undeniable presence. And it appears in a place scientists have already searched extensively, using every model of Titan's atmosphere they've built over decades of study, and every catalog of known molecular signatures ever assembled. It isn't there, which means one of two things. Either this is a known molecule behaving in a way no one has ever documented before, under conditions no lab on Earth has fully replicated, or it's something else entirely. A compound that has never been identified anywhere, on any world, in any spectrum, ever recorded by human instruments. If it's the second option, this wouldn't just be a Pluto story or a Titan story. It would be the discovery of a genuinely new molecule, hiding in plain sight, on two worlds we've been staring at for years. Here's what's confirmed. The signal is real. It appears at the same wavelength on both Titan and Pluto. It was measured independently, using two different instruments, and it doesn't match any molecule currently in scientific databases. Here's what is not confirmed. One leading idea is that the signal could come from benzene, a ring-shaped hydrocarbon, possibly mixed with other organic compounds. Titan is already known for complex organic chemistry. It's essentially a natural factory for hydrocarbons, raining down reddish-brown particles called tholins that give the moon its hazy orange color. Pluto has its own haze too, a thin, bluish layer high in its atmosphere that scientists confirmed with Webb plays a real role in regulating the dwarf planet's climate. So, the working theory is that both worlds are running some version of organic chemistry in their atmospheres or on their surfaces, and this molecule is a product of that process. But that's a theory, not a confirmed identification. Scientists have not matched this signal to any laboratory sample yet. They don't know if it's one molecule or a family of related compounds. They don't know why a world as cold and airless as Pluto would produce the same signature as a moon with rain, rivers, and a dense atmosphere. The honest answer from the researchers themselves is that this is genuinely mysterious. Not manufactured mystery for a headline. Real, open, unresolved. Two of the strangest worlds in our solar system. One buried in ice at the edge of the dark. One wrapped in orange fog with rivers that have never known water. Nothing about them should match. And yet, somewhere in their chemistry, they are writing the exact same signature into the light they send back to us. We don't have a name for it yet. We don't fully understand it. But it's out there right now, on two distant worlds, waiting for someone to finally read what it's trying to say. Sometimes, the universe doesn't reveal its secrets all at once. Sometimes, it just leaves the same clue in two impossible places and waits to see if we're paying attention. If you like the video, subscribe the Deep Space channel for more mysterious videos.